Okay, we're doing section 4.3. This is problem number 1. Background information that is here, you're dealing with quadratics, the parabolas, and instead of y equals ax squared plus bx plus c, you're going and using it in function notation, but it's predominantly the same as it's always been. If a is greater than 0, it's positive, it opens up. If a is less than 0, it opens down. Your axis of symmetry is the vertical line right here that goes straight through the vertex, regardless of the direction that it points. You've got some properties of quadratics. You can use this form to find the vertex, negative b over 2a. You find the x value, or the h, whichever you want to refer to it as. hk a lot of times is the vertex. Once you get that, then you would plug into your quadratic to get the y value, the function value. One of the things that you can kind of tell a little bit about is by finding the discriminant. The discriminant is the b squared minus 4ac. That's part of like the quadratic formula. That's greater than 0, you have two distinct x-intercepts. If that is equal to 0, you will only have one x-intercept, and that is actually the vertex of the parabola. And if b squared minus 4ac is less than 0, the graph would never touch the x-axis. You would only have imaginary roots, and so in real numbers it does not exist, doesn't have any x-intercepts. And these are the kind of like the three scenarios that you would see: two intercepts, one intercept, and no intercepts. The vertex is hk. This is kind of like known as the vertex form, in that hk is your vertex. It makes it kind of easy to plot the vertex if it is in this form. Now, the first one is more or less like referring back to, I think it was section 3.5 with transformations. They want you to graph this based on a transformation. So you will look just like you always did. The parent here is y equals x squared. It looks like this with a vertex at 0, 0. Its axis of symmetry is x equals 0. Its domain is all real numbers. The range is 0 to infinity. That's the parent. Now, the transformations that would take place. This would be left 2 units and up 6 units. Horizontal translation is usually done first. That is left 2 because of the plus 2. There is no stretching or shrinking involved. There is no reflecting involved, but there is a vertical translation that is up 6 units. Remember, this is the order to do the transformations in. And if you graph that, you notice the point that I originally had at 0, 0 is now at negative 2, 6. Of course, some of the things have changed from it, but it is the same basic parabola that has just simply moved there. Doing it with MyMathLab, you click on the quadratic and you click the graph, and it'll automatically send the vertex to 0, 0. Then you will do the horizontal shift. You will make it go left 2 units, and since there's no stretching, shrinking, or reflecting, you don't have to deal with that. The vertical shift is up 6, so you would go and pick it up and move it to 6, and then you save it, and you see that the vertex here should be at negative 2, 6. These are just different setups as far as your each little block means the same kind of thing, but they look a little different, but it's really the same, just whatever your window has been set for and so forth. And what actually happened, the vertex moved to negative 2, 6. The axis of symmetry, which was x equals 0, is now x equals negative 2. The domain was all real numbers. It's still all real numbers, negative infinity to positive infinity. And the range was 0 to infinity, now it is 6 to infinity. I hope that gives you an idea and a review of transformations with parabolas.